Hello everyone, welcome to my YouTube channel. This is Priyanka Ghosh and this video is for your upcoming Army Public School Teacher Recruitment exam. This video is helpful for PGT Physics students. Today's topic is motion in a plane. So let's get started. See the first question. The diagonals of a parallelogram are given by calculate the area of parallelogram. The area of parallelogram is half into mod value of d1 and d2. Here d1 and d2 indicates the two diagonals of the parallelogram, and so that means at first we calculate the cross product of these two diagonal, that is d1 and d2. So let's arrange these two vector as per the requirement. So this is the arrangement, and first calculate the cross product of d1 and d2, that is I 2 plus 8 minus j minus 3 minus 4 plus k minus 6 plus 2, and it gives 10i plus 7j minus 4k. Here the mod value of this vector is required. So that means how do we find the mod? That is root under 10 square plus 7 square plus 4 square. So it gives 100 plus 49 plus 16, and we get here root under 165. 165. Now put this value into the formula, that is half into root under 165 unit. But 165, this is not a perfect square root number, right? So how do we find out its value? We know the 13 square is 169, so this value is close to 169. If the number is 169, so that means we get 13 by 2 and it gives 6.5. So we can say this value is very close to 6.5, right? And here we can see option number A, it is 6.4. So here 6.4 is our correct answer. Moving to the second one. A particle is moving such that its position coordinates are 2 meter, 3 meter at time t is equal to 0, 6 meter, 7 meter at time t is equal to 2 seconds, and 13 meter, 14 meter at time 5 is equal to at time t is equal to 5 seconds. Average velocity vector from t is equal to 0 to t is equal to 5 seconds is. At first, let's find out the distance that is covered along x-axis. And how do we calculate this one? That is final distance minus initial distance. That is final distance, that is at time t is equal to 5 seconds, that is 13 meter, and at time t is equal to 0, that is 2 meter. So just 13 minus 2 meter, and it gives 11 meter. In the same way, we are going to calculate the distance that is covered along y-axis within 5 seconds, and it is 14 minus 3 meter, and it is 11 meter. Let's find out the average velocity vector. Average velocity we can write here xi plus y j divided by t, and it gives 11i plus 11j divided by 5. So option number D is the correct answer. Moving to the next one. Two particles having position vectors r1 and r2 are moving with velocities v1 and v2. If they collide after 2 seconds, the value of A. Suppose this is one body and this is another body. These two bodies these two bodies collide with each other after t seconds. So that means we can say within t second the first body and the second body covers the equal distance. I am repeat, these two bodies collide each other, so that means we can see the first body and the second body covers the equal distance within t second. So this is the required condition. So as per this condition, we can say here r1 position vector plus v1 t is equal to r2 plus v2 t, right? So put this value 3i plus 5j plus 4i plus 3j into t means 2 second, r2 that is minus 5i minus 3j plus v2 ai plus 7j, and here t is equal to 2 second. Solve this one. 3i plus 5j plus 8i plus 6j is equal to minus 5i minus 3j plus 2ai plus 14j. If we calculate this one, it gives A is equal to weight. So option number D is your correct answer. See the fourth question. A body is projected horizontally with a velocity 40 meter per second from the top of a building. After what time the horizontal and the vertical velocities of the body become equal? First, draw the diagram. And this is our top of the building. At first, this body is at rest. From this top position, this body is projected horizontally, right? Okay, this is the required diagram. We can say from this diagram the horizontal velocity, that is denoted by Vx, is equal to 40 meter per second. Why? Because we know there is no acceleration along x-axis, only we can see only accelerated motion only along y-axis. There is no acceleration along x-axis. We can see here the accelerated motion along y-axis only. So let's find out the final velocity along y-axis. So what is the equation of motion? Vy is equal to uy plus at. Here uy is equal to 0. Why? Because the particle is at rest, and a is equal to 10 plus 10 because the body is projected in the downward direction, that is 10 into t is here the required time. Okay, so we can see here vy is equal to 10 t. So as per the condition, we can write here Vx is equal to Vy. So 40 is equal to 10 t, and we calculate, if we calculate this one, it gives t is equal to 40 second. Here option number B is your correct answer. Moving to the fifth question. For angles of projection of projectile at 45 degree minus theta and 45 degree plus theta, the horizontal ranges are in the ratio of. Here we can pick the correct answer, that is B, option number B, 1:1. There is no necessity for doing anything. Why? Because this is the one angle of projection, this is the another angle of projection. If we add these two angle, it gives the 90 degree. Okay, if the two angle of projection, if we add these two angle of projection and we get a 90 degree, so that means we can say directly the ranges are in the ratio of 1:1. Suppose one angle of projection is 60 degree and another angle of projection is 30 degree. Now we add these two angle, it gives 90 degree. So we can say R1 is to R2 is equal to 1:1 directly. There is no requirement of doing anything. Okay, so moving to the sixth question. A particle is projected at an angle theta with the horizontal. If the angle of elevation of highest point of trajectory is phi when seen from point of projection, then they are asking me to find out the relation between phi and theta. So at first we are going to draw the required diagram. This is the diagram. This particle is projected at an angle theta. So this is the u, velocity is projection u, and this is the angle of projection, and this is the angle of phi as per the question. Okay, so we can see here this is the triangle ABC, and the height of this triangle is A, that is the height of this projectile motion, and here BC, that is the base. We can write here R/2. Here R denotes the range of this projectile motion. From this triangle we can write here tan phi is equal to h by r by 2, that is 2h by r. Put this value, that is 2 into h, that is the u square sin square theta by 2g, and r, that denotes range of this motion, that is u square sin 2 theta by g. Let's solve this one. Tan phi is equal to 2 cancel out, g also cancel out, u square cancel out. Here we write sin square theta, next 2 sin theta cos theta, and 1 sin theta cancel out, and it gives half tan theta. We write here tan phi is equal to 2 tan phi is equal to tan theta. So that means option number C is your correct answer. I hope you understood it. Next, seventh question. A small ball is projected from 0 meter in xy plane at t is equal to 0 second. Its velocity at time t is equal to 1 second is that is in vector form, horizontal range of this ball. So they are asking me to find out the horizontal range, and this is your previous NVS question. At first we draw a diagram. So this is our projectile motion, this is our the initial velocity or velocity of projection, and this is one is the angle of projection, this is the x-axis, and this one is the y-axis. Here after t second, that means after 1 second velocity is given. So that means we can say here Vx, that is 32 meter per second, and Vy is equal to 14 meter per second. So this is our final velocity after 1 second. So we don't know what is the initial velocity, that is Ux and Uy. We can write here U cos theta, that is the velocity along x-axis, and U sin theta, that is the velocity along y-axis, right? Here we write Ux is equal to 32 directly. Why? Because we all know there is no acceleration along x-axis. The accelerated motion is only y-axis. We can see here the accelerated motion along y-axis only. So that's why we write here 32 as our initial velocity along x-axis. Let's find out the initial velocity along y-axis. What is the equation of motion? That is Vy is equal to Uy plus gt. This is our equation of motion. Put this value, that is 14 is equal to Uy plus g, that is minus 10. Why? Because this object is projected in the upward direction, and here t is equal to 1. It gives Uy is equal to 24 meter per second. Now what is the formula of horizontal range? R is equal to U square sine 2 theta by g, right? This is the formula to find out the range, but we can write here this formula, that is Ux into t. This is also the right one, now. This is also right, and this one is also right, but we choose the second one. Why? Let's see. Why do we choose the second one? From this equation we get here the initial velocity along y-axis. Okay, so next we find out the time of flight, that is t is equal to 2u sin theta by g. Okay, 2 u sin theta. What is the formula of u sin theta? It is our the y component of initial velocity, right? So here we put 2 24 by 10. This is our time of flight. Now put this value here. What is the formula of UA? That is 32, and 2 into 24 by 10. If we solve this one, option number C, that is 153.6 meter. This is our final answer. I am saying it once again. Here they are asking me to find out the horizontal range, and this one the formula. Okay, if we solve this one, we here sin theta cos theta both are coming, right? But this is more easier if we choose the second one, that is Ux into t, that is time of flight. If we choose this formula and solve this math in this way, it is more easy to get the final result. Okay, I hope you understood it very well. Moving to the 8th question. A projectile is given an initial velocity of that is the I plus 2j meter per second. Here I is along ground and j is along the vertical. G is equal to 10 meter per second square, the equation of trajectory. uh, so here the initial velocity is given, so that means u is equal to I plus 2j, that is given initial velocity, and this is our uxi and uyj. So here the uh, initial velocity along x axis, that is 1 meter per second, and the initial velocity along y component, that is 2 meter per second. Okay, now we are going to find out the distance that is covered in t second along x axis, that is denoted by fx, that is uxt, that is our equation of motion, and half ax t square. Put this value, it gives 1 into t plus 0. Why? There is no acceleration along x axis. Here we get x is equal to t. In the same way, we calculate the distance that is covered along y axis in t time. Y is equal to uyt plus half ay t square. Put the value uy, that is 2t plus half minus 10 into t square. It gives 2t minus 5 t square. We solve this one. Y is equal to 2t minus 5t square, and we also know x is equal to t. Put this value in place of t, that is 2x minus 5x square. So what is the final result, or what is the equation of trajectory? That is y is equal to 2x minus 5x square. Here option number A is your correct answer. I hope you understood it. Ninth question. The position of a projectile launched from the origin at t is equal to 0 is given by r at t is equal to 2 seconds. The projectile was launched at an angle theta from the horizontal. Find the maximum height. This is the projectile motion, and here the velocity, initial velocity, that is denoted by u. This is the angle of projection. So here it is u cos theta along x axis, and here it is u sin theta along y axis. Okay, here position vector is given, that is r is equal to 40i plus 30g. Okay, sorry, 30j. The maximum height, that is h. How do we find? The formula is u square sin square theta by 2g, right? We can write here u sin theta whole square by 2g, or we can write here u y whole square by 2g. This is also correct. So that means we can say at first we are going to calculate the initial velocity along y direction, that is required. So first first write down the equation of motion, that is y is equal to uyt plus half g t square. Okay, here we are considering here only only y axis. Okay, here y that is 30, that is given. We don't know the value of uy. T, that is given after 2 seconds, plus half g minus 10 into t square, that is 4. From this equation we get 30 is equal to 2 uy, and it gives minus 20. Uy is equal to 25. Okay, now put this value here. 25 into 25 by 2 into 10. Now if we solve this one, we will get option number C. Option number C, that is 31.25 is your correct answer. I hope you understood it. Next, last question, that is 10th question. A particle is moving in a circle with radius 0.3 meter. Calculate its resultant acceleration at the instant when its angular velocity is 1 rad per second and angular acceleration is 4 rad per second square. So as per the question, here omega, that is 1 rad per second, and alpha 4 rad per second square are given. So what is the formula to find out the resultant acceleration? That is at whole square plus ac whole square. At, it denotes the acceleration that is along tangential, that is it is our tangential acceleration, and it is our centripetal acceleration. The formula to find out the tangential acceleration is r alpha. R 0.3, alpha, that is 4, and it gives 1.2 meter per second square. And what is the formula to find out the centripetal acceleration? That is ac is equal to r omega square. R 0.3 omega square 1, and it gives 0.3 meter per second square. Put this value into the formula. 1.2 whole square plus 0.3 whole square, it gives root under 1.44 plus 0.09. We add this one and we get 1.53. Now how do we calculate the final result from this one? We know 12 square is equal to 144 and 13 square is equal to 169. Okay, from seeing this value, we can say the value is between 12 and 13. Okay, and after seeing this option, we can put the correct answer directly, that is 1.24 meter per second square. That is very close to this value. Okay, so this is our final answer, and in that way you can choose the correct answer also. There is no requirement to find out this whole thing. Okay, so this is one is our correct answer. So that is for today. I hope you all are enjoying this class. If you like this class, so don't forget to subscribe and like my channel. That is for today. Next day we will do another set of mock test. Till then, bye bye.